Okay, so now let's go a little bit back to basics, and let's just go into answering this question: How do we solve? Oops, sorry. How do we solve programming problems? Okay, so this is a very complex question. It might seem simple, but it implies logical thinking. It implies logic, and that is what I'm trying to teach you guys in this course. Okay, so this is basically uh, the point of the whole course. Okay, so I can start teaching you how to solve programming problems. I can maybe write down a small methodology. Again, this methodology will not necessarily will be like accurate steps to how to solve programming problems, but it might help you start. Okay, so first things first, you have to remember what I said on the first classes, that computers are stupid, okay? So in order for a computer to do a certain task, you need to tell it step by step what to do, okay? So you need to start first thinking in steps, okay? That is what logic is, thinking in steps. So I'm gonna write that down, thinking in steps, okay? So the more accurate, the more steps you think of to solve a problem, the more accurately the computer is going to solve that problem. Okay, so take for example, and I'm going to make this problem uh, with PCInt. So take for example, okay, given a number, print, let's say print the countdown, of that number. Okay, so if I give the computer 3, then it's going to print 3, 2, 1, 0. Print the countdown till 0. Okay? So if I give the computer program 4, it's going to print out 4, 3, 2, 1, 0. Okay? So now we know what we want to do. Okay, so given a number, you're going to print the countdown until we reach 0. Okay, so step number 1 in this methodology is to figure out variables. Figure out variables. Okay, we need to figure out variables. So let's look at our program. Let's think of it as a black box. So we still don't know what's going on inside here. But variables are things that are going inside. So user specified, there can be 2 types of variables. The ones that the user specifies or internal, okay? The internal variables are going to be a bit harder to understand. Sorry, my dog is making a lot of noise. So the user variables are the ones the user is going to identify. So these ones we can figure out at this step. The internal variables, we still don't know how to manage them, but the methodology will eventually lead us to these. Okay, so don't worry. So the user specified variables are the ones that go in here. The ones that the user, so user variables, the ones that the user wants to input to the program, and eventually the program will give us some result. Okay. So step number 1 would be to identify these user variables. Okay. What am I going to give the program? Right now, look, given a number, print the countdown until 0. So the input is definitely going to be a variable, okay? In this case, we're going to input a number, okay? And more specifically enough, that number is going to be an integer. Okay? Because I'm not giving the computer, for example, 2.5. Okay? I'm not giving that computer that number. We're only giving it integers, okay? So, since we're inputting a number and it's an integer, well, we can say that this is one thing that's going to be varying within the code. So this is a variable, okay? If it varies within the code, it's a variable. So let's call this variable. At this point, you can call it whatever you want. So normally, when I talk about numbers, input numbers, I'll just call it, our variable's name will be n. Okay. So that is right now what we want to give, right? The result is not a variable. Why? Because you're just going to be printing out this number. But okay, we can always output. We can print it out directly, but we can also store it in a variable. Okay, so let's call the output are going to be also numbers and integers, and it's going to be called. It's also this thing could also be a variable, and let's call it R for result. Okay. So now that we figured out what variables we want, we don't know yet how to figure out this internal variables, but at least the user specified ones, the input and the output, we already specified them. Okay. So now step number 2 is to figure out the logic. So in this step, when we figure out the logic, we can actually figure out if we're going to be needing internal variables. Internal variables are auxiliary variables that are going to be used inside this code in order to transform this into this. Okay, so right here we'll have internal variables. And remember that they are variables that help us transform these variables into these ones. Okay, so we need to figure out the logic. And how do we figure out the logic? Well, it's simple enough because you guys already know how to do these things, okay? So given a number, print the countdown until 0. So think of yourself as a machine, okay? So if I give you number 3, you need to print the countdown until you reach 0. So remember, think like a stupid machine. You're giving a number 3. What do you do to that number? What do you do to that number to print out the countdown till 0? Well, you know that the next number in that series would be 2. Okay? And 2 is equal to 3 minus 1. So once you do 3 minus 1, you print out that result. Have you got, at this point, you know that you haven't reached 0. So you have to continue doing this process until you reach 0. So how do we know if we have finished? How do we know when we have finished? Well, we know we finish when 0 is reached. Okay? So you're given 3. So this is the input. You're given 3, and then you subtract that number. You subtract 1 from 3, and you print out this number. You would have to check if this number is greater than 0, greater or equal than 0, because we know that we need to finish until 0 is reached. So we need to know if this number is 0. So in order for us to figure out if we have finished or not. So we have to compare this number to 0. We know it's not 0, it's greater than 0 actually. So we do the process again. We take this number and then subtract 1. So that gives us as an answer 1. 1 is equal to 2 minus 1 equals 1. Now we have this number right here. We print it out and we check if this number is greater or equal to 0. Why? Again, because we are stopping until we reach 0. Since 1 is greater or equal to 0, then we know that we have not yet reached 0. So we do the process once again. We take this number and we subtract 1 and we get 0. We print out this number right here and we check if this number is greater than or equal to 0. Since now it is greater than or equal to 0, we know we need to stop because we have actually reached 0. Okay? So once we reach 0, then we can continue and print out these numbers. Or you can print them out every single time that you do the cycle. So now we know that there must be some sort of cycle involved here. Okay? And this cycle must repeat itself until some sort of counter reaches 0, right? Sorry for that 0. So reaches 0. So now we know that since we're going to be using a counter, Let me put it up here because it's a horrible 0. Reaches 0. There we go. So now we know that since we're going to be working with a counter, with a cycle, this implies, almost always implies, that we are going to work with a counter. Therefore, this will be an internal variable. Counters are internal variables. So we have identified that we need to define an internal variable here. So this will define our internal variable C, which is our counter. Okay, so I'll just finish this thing right here, and on the next video we can see how we can put all of this logic into a working flowchart. Okay, so thank you.